Hey guys, Rosado here again. So this week's going to be a pretty short one. All we have is the fundamental forces, which is easy to say that's all we have, but they literally underpin everything that happens in the entire universe. So we'll go ahead and jump right in. So the fundamental forces. So all interactions in the universe can be broken down into four fundamental forces. The reason we call them that is because we can't go any lower than that. Once we hit these four, they underpin everything. So we have gravity, the weak nuclear force, the electromagnetic force, and the strong nuclear force. And we'll talk about each of these forces individually. And then down here we have a comic clearly explaining all the forces to you. So gravity. Gravity we're very familiar with. We experience it every day. Have you ever fallen down? Have you ever thrown something up in the air and had it come back down to you? Ever thought about how nice it is that you don't just float away up into space? Gravity is what you have to thank for this. On a basic level, we could say it's just interaction between anything with mass. So any two objects with mass, including you and your phone, you and a ball, you and the earth and a ball, the sun and the earth, anything with mass is exerting gravitational force on something else with mass. So this includes you and the sun. But clearly, one of those is going to have a stronger gravitational attract. Or one of them is going to be affected more by the gravitational force. You would be the one affected more by this force because you're smaller. This force only attracts. The most extreme example of gravity in action is something like a black hole. Have you ever heard of a black hole that spits things out? Probably not. You've only ever heard, hopefully, of black holes that suck things in. They attract the stuff around them, and this is gravity doing it. Gravity only attracts. Now, even though we have examples of the sun holding all the planets in orbit, the earth holding you down, black holes eating all the stuff around them through gravity, gravity is actually the weakest of all the fundamental forces. Think about it. If there's something sitting on the table, I can lift it up. I've beaten gravity. It's not difficult to overcome the force of gravity. Even the force of gravity of something so massive as the Earth. You ever jumped up in the air? Congrats. You overcame gravity, even just briefly. So gravity is incredibly weak. Even when you have tons and tons of mass, millions, billions of kilograms, it's not enough to have a appreciable gravitational effect. And it acts across infinite distances. So the sun is clearly holding all the planets in orbit. The sun is 93 million miles away from us. We have the Andromeda Galaxy, millions of light years away from us, but it is still being pulled towards the Milky Way through gravity. So gravity acts across infinite distances. Even if it might be so weak that it doesn't actually do anything, it is still going to be acting on those objects. And so basic examples, planets being held in orbit, throwing a ball up in the air and it falling. All right, weak nuclear force. This one is going to be less familiar to. So this is an interaction between the particles that actually make up protons and neutrons. This is an idea you may be unfamiliar with. So we've always talked about how the atom is made up of the proton, neutron, and electron. And for a very long time, that's all we thought there was. Like, that's the farthest you could go. Well, it turns out you can zoom into protons and neutrons and see other things inside of them. Protons and neutrons are made up of particles called quarks. These are the particles that actually make up things like protons and neutrons. There are only two types of quarks shown here. There's the up quark and the down quark. You don't really have to know those things. The idea is the weak nuclear force is their way of interacting with each other. It can actually cause the quarks to change their flavor. And this isn't a term I'm making up. It's called their flavor. So an up quark can become a down quark or vice versa. This is what's causing radioactive decay. Remember how we talked about beta decay last week? Beta decay is happening because the weak nuclear force is causing these quarks to change. So this is radioactive decay. This is also very, very important in nuclear fusion. So without this, stars wouldn't be able to burn. And if stars couldn't burn, you wouldn't have any life because there wouldn't be any heat. There wouldn't be any energy for life to develop. Now, incredibly important, but it can only act on extremely short distances. This only happens within the nucleus. Remember, it's just the things inside of protons and neutrons that are affecting one another. So incredibly short distances. A force you're a lot more familiar with, electromagnetic force. This is an interaction between electrically charged particles. So two positives repel, two negatives repel, positive and negative attract. So this is where we were talking about opposites attract, likes repel. We talked about this right before we left and school was paused. You know, this force is actually responsible for almost every interaction in our daily lives. You being able to see when you touch things, friction, all those interactions between objects are happening through the electromagnetic force. Magnets, electromagnetic force. Heat, electromagnetic. So almost everything that you do on your daily life is related to the electromagnetic force. And it's named that because it's a combination of the electric and the magnetic fields. So it shows you here, electric and magnetic. And this acts across infinite distances. So light is able to travel millions and millions of light years. Even if the force is so weak it won't do anything, it can still act across vast distances. And the strong nuclear force. So the strong nuclear force is the force responsible for holding those quarks we talked about a couple minutes ago together. So the up and down quarks are held together through the strong nuclear force, and that creates a proton and a neutron. Now, we also talked about in the previous week how protons in the nucleus, well, they're all positive, and they're trying to push each other away because they're positives. That's electromagnetic force at work. Well, thankfully, they don't just fly apart because, I don't know about you, but atoms are kind of important. They make up everything. That's also why you shouldn't believe them. But since they make up everything, we kind of need them to exist and to have things like matter. So the strong force, what it does is the strong force holds protons and neutrons together. So not only does it actually make the proton and neutron itself by binding the quarks together, but it holds the protons and neutrons together once they're made too, and it forms a nucleus. So the strong nuclear force makes the protons and neutrons by holding the quarks, and then it holds those protons and neutrons together in the nucleus. Incredibly important. And it can only act on extremely short distances. This force is only meant to happen inside the nucleus, so it doesn't need to go much farther than that. So this only acts within the nucleus. Here is a summary table. So here are your four fundamental forces. They are listed here from strongest to weakest. The strongest force is thankfully named the strong nuclear force. So strong nuclear force, strongest force will give him a strength of 1. And his range obviously is only within the nucleus. And that force only attracts. The strong nuclear force does not repel. It would kind of suck if you had the protons and neutrons in the nucleus and they decided to repel each other. Imagine all the atoms around you just suddenly exploding. The electromagnetic force is the next strongest. So these are arbitrary strength values. The idea is just to compare their strengths to each other. So the electromagnetic is the second strongest. Its range is infinite, as we mentioned, and it can obviously both attract and repel. Two positive charges will repel each other through the electromagnetic force. A positive and a negative will attract each other through the electromagnetic force. And now, unfortunately, the weak nuclear force is not the weakest force. even though it's got weak in its name. The weak nuclear force is the third strongest, and it only acts within the nucleus. Remember, it's how those quarks interact with each other. And then the weakest force by far is gravity. Gravity is the weakest fundamental force. It takes huge amounts of mass for there to be an appreciable gravitational force. Its range is infinite, and it only attracts. There are no black holes that spit things out. The sun isn't suddenly going to decide one day to fling the Earth away. Its gravity is not going to suddenly push the Earth away. Same with the Earth. It would suck if one day the Earth's gravity reversed and all of us were just shot into space. Thankfully, that's not how gravity works. So those are your four fundamental forces. As I told you guys, it's going to be a short one. That's all we have to do this week. So go through those. Make sure you're ready for your quiz. Remember, only the stuff in the video here is the stuff that I'll quiz you over. If there's something Edgenuity mentioned that I did not mention here, it won't be on your quiz. So make sure you know the forces, know what they are, know examples of them, know like their range and their relative strengths. Use Edgenuity to practice. If you have questions, let me know. I'm obviously very available. I'll have office hours on Thursday. I'll be taking questions through email. So if you need something, just let me know. In the meantime, be sure to like and subscribe, and I'll see you guys in the next one.